Hello, my name is Oliver Alt. I'm from Lieber, and I want to present you today about Enterprise Architect in automotive development with AUTOSAR and ISO26262 functional safety management. Lieber is an Austrian software company with location in Vienna. We are a partner company of Spark Systems. Spark Systems is a modeling tool provider and the vendor of Enterprise Architect. And I want to tell you about the possibilities of automotive engineering with Enterprise Architect. Further areas of our company besides model engineering with Enterprise Architect are multi-touch engineering and .NET software engineering. Spark Systems Enterprise Architect is a UML and SysML modeling platform. With more than 300,000 users worldwide, it is a widely used tool in all kinds of industries and domains. It is used for business, software, and embedded engineering. Enterprise Architect is an open platform. You can extend the tool out of the box with own plugins, scripts, and language extensions, so-called UML profiles, to fit your own requirements, not covered by the tool out of the box. In automotive engineering, you have many challenges for the development. At the base, you have different process models and process norms you have to fulfill, like SPICE or Automotive SPICE or CMMI or perhaps the INCOSI systems engineering process. On top of these base processes, you have further norms for functional safety management, like the IEC 61508 or the ISO 26262 for containing special requirements for the functional safety management. And beside these base processes and functional safety management norms, we have different further challenges in the development area in automotive engineering, like development with the AUTOSAR standard in software engineering, or C code generation. You can today, if you make model-based engineering, you can use these models to generate code. In domains like HMI, in domains like multimedia and car multimedia, you have things like user interface modeling. And one big topic for all these process norms is a full traceability through all kinds of work products and the complete product lifecycle. In systems engineering, you have normally three building blocks. The first building blocks are the requirements. Requirements are normally defined as text. With these textual requirements combined is the architecture. The architecture describes the structural parts of the system, their interfaces and interconnections. And the third building block in systems engineering is behavior. Behavior is also contained in the requirements texts, but what is meant here is a more formal behavior, like a behavioral model in UML, for example, a state chart model, or a behavioral model in MATLAB Simulink, for example, where code or test cases can be derived by tooling. So the behavior meant here is more formal behavior. When you use model-based systems engineering, then you have a model as a central database for your development. And the difference to the classical document-centric process is that this model is has a formal structure, and you can manipulate and put data in with tools. And what kind of structure this model has, this is defined by the processes. And when you use tools to manipulate or derive new data from this model with tools, then work products can be derived from these models automatically. So model-based systems engineering has basic principles like automation. You can do things with tools and you can steps automate. Then tool data integration. In many development areas you have not only one tool, not only Enterprise Architect, for example, but you have many tools, a tool for requirements management, a tool for functional safety management activities like FMEA and so on. And you have to integrate these tool data, so one tool can reuse the data from another tool. So you have not to input the tool data again in the next tool following in the tool chain. And the third step is model transformation. Model transformation is defining rules. What kind of data have to be transferred to a new format? There's another tool can read this data again. Or if you want to generate, for example, documentation or test cases, then the model transformation rules say how the model data must be converted, that the target data is generated correct. In model-based systems engineering are many standards defined. We have, coming from the software engineering domain, the UML, the Unified Modeling Language. Then for systems development in combination of hardware and software components, the SysML, the Systems Modeling Language for systems engineering. In software engineering in automotive domain, we have the AUTOSAR standard with the virtual function bus modeling. And for requirements management is now defined the RECIF as requirements interchange format to exchange and create data for requirement engineering. Liber will provide you many kind of products and solutions for systems engineering for all kind of building blocks available in systems engineering. For the requirements building blocks, we provide you NREC. This is the requirement integration approach for Enterprise Architect. On the architectural side, we have extensions for SysML and for functional safety modeling to enhance the standard capabilities of Enterprise Architect for an easier and more convenient way to model systems engineering models and system architecture models. For AUTOSAR, we provide you modeling standards matching the VFB modeling standard for AUTOSAR 4.0. And for the behavior building block in systems engineering, we provide our tool Amuse for advanced modeling using simulation and execution to generate code and simulate and execute behavioral models from UML and SysML. Now I will give you examples for the different kind of integrations and Liber solutions for systems engineering. At first, the NREC requirement integration. I have here an example scenario. You see Enterprise Architect on the right side and a requirement repository. This might be a DOS, an MKS, or a Polarion repository on the left side. And you can now transfer data via the NREC requirement integration between Enterprise Architect and the requirement repository. It is important that one side is the master and one side is the slave. So typically Enterprise Architect is the slave because beside Enterprise Architect, a requirement management system is used. So all kind of changes are done in the master, and the slave has only a representant or a link to the element in the master repository included. And by including the elements from the requirement repository into Enterprise Architect, you can then relate these elements in the Enterprise Architect model to other elements like architectural elements and so on. The next example is the AUTOSAR virtual function bus modeling with Enterprise Architect. You see here an example taken from the AUTOSAR standard specification of a virtual function bus model. We are able to provide you the UML profile to support the AUTOSAR modeling standard, so you can use the AUTOSAR modeling symbols with Enterprise Architect. It is also possible to combine these kind of diagrams with other diagrams in the Enterprise Architect model, like SysML models and SysML diagrams. For the functional safety management, it is also possible to enhance Enterprise Architect with special kind of symbols and special kind of extensions. For example, for the task of ASIL decomposition defined by the ISO26262, we have here elements with an ASIL level assignment. It's also done in the Enterprise Architect model and is displayed in the diagram here, for example, here in ASIL C for the components here. Also, we have a coloring of safety mechanism components. So you can see on the first side, if you open a diagram, that these kind of components with this red color are safety mechanisms and used as safety mechanism. So you can differentiate between the normal functional architecture and additional mechanisms needed for safety architecture. You have seen different types of diagrams and extensions for Enterprise Architect that enables you to fulfill your process requirements for the automotive development area, like functional safety management or AUTOSAR. And all the presentations, extensions, technologies and methodologies can be combined with EA, because all information is stored in the common Enterprise Architect repository and can then relate it to each other, because it is stored in a common database used by Enterprise Architect. And traceability between the elements is also easy to ensure and to handle, because the requirements are now part of the model, the AUTOSAR modeling is part of the model, and other things like a SysML model is part of your system model, and you can relate every element to any other element and so ensure a total traceability over the entire system model. This presentation has only shown a few possibilities of Enterprise Architect for using in context of automotive development. There are many more possibilities not part of this short tutorial here. Enterprise Architect has a powerful document generation engine built in, or this generation engine can extend it via plugins, for example the EA-docx plugin. We have also simulation and code generation possibilities in Enterprise Architect available for the PC application domain or for the embedded code domain. This can be done by built-in technologies like the code generation templates and the code generation engine, or by extensions, for example the Amuse extension for C# and C code generation, and also available is Amuse in combination with the Willard framework. And these are only a few more possibilities, there are many more. So thank you for watching this short presentation. feel free to contact us for further information and to get more information about the presented tools and presented extensions. Thank you.